right? Let's take a look at something slightly different. And I think we're on question 4. And the next question is we're integrating 4 sine squared x over 2 dx. Let's recap, instead of scrolling up and down, let's recap some of those identities. And one of them is cos 2x. And cos 2x is 1 minus 2 sine squared x. Okay, so let's manipulate this a little bit. So I can say cos 2x. Actually, I can go, let's move this one over here. So sine squared x is equal to, move the 1 minus cos 2x over 2. All I did is just manipulate the last, this identity here. So I went 1 minus cos 2x from both sides, and then minus sine squared x from both sides, 2 sine squared x from both sides, and then divide by 2. Just manipulate this a little bit. Okay. So let's go back here to my question. So the 4, I can kick the 4 out of the integration. I don't integrate constants. And then I've got sine squared x over 2. So this, if this is x over 2, right, then this is double it. So double x over 2, it becomes x, right? So I'm going to have 1 minus cos x over 2 dx. Let's try this one again. You've got x here, you've got 2x here, right? So I've got x over 2 here, so I'm going to double x over 2. X over 2 times 2, which is x, and that's why I now have x. It becomes 1x, right? So let's finish it off. 4 divided by 2 is 2, and then you're integrating 1 minus cos x dx. Easy peasy. Equals 2, and then let's integrate, bracket, let's integrate. The 1 becomes x. The 1 integrates into x because 1 is x, remember, 1 is x to the 0. Increase the power, divide by the new power. Increase 0 into 1, divide by 1, so it becomes x to the 1. Minus cos x, so let's try it here, sine, cos, minus cos, and I'm integrating, so I'm going this way, here, so all the way here, so cos should be sine. So straightforward, so minus sine x plus c. And you can leave it like that, or you can choose to expand the brackets, it's entirely up to you. You can leave it as factorized. Right, let's take a look at the next question, and the next question is, I think we're on 5 at the moment, and it's cos x plus sine x all squared dx. I'm integrating a bracket of cos x plus sine x all squared. Excuse me. Now this is the same as having 2 brackets, cos x plus sine x multiplied by cos x plus sine x. Right? And you can use FOIL, you can use Freddy Frog, you can use any method you've been taught in school. It's perfectly fine. So let's take this out, rub it off, and let's expand it, because I'm pretty sure you can expand it without having to do all that. So this is equal to, we're expanding, so we're going to have cos squared x plus sine squared x plus 2 sine x cos x dx. And that's after you expand the brackets. I should have written the 2 sine x cos x in the middle. It doesn't really matter, but I'm just taking shortcuts. You'll find out why in a second. Okay, very straightforward. Just expand the brackets. And then I'm going to think, now from the identities, I know that cos squared x plus sine squared x is equal to what? 1. One of the identities you should know. So in fact, all that will simplify into 1 plus, this is the plus, 2 sine x cos x dx. This is here, and this is this bit here. Okay, sine squared plus cos squared equals 1. Now, what is 2 sine x cos x? You can scroll to your notes and take a look at the double angle identities and what is 2 sine x cos x. And 2 sine x cos x is sine 2x dx. So this bit here is sine 2x from the double angle identities. It looks very simple to me. Now I can integrate straightforward. So 1 will integrate into x plus sine will integrate into cos minus cos. And because there is a k, so I'm going to go minus 1 over k, k is 2, cos 2x plus c. And I can rewrite it and take this plus away and put the minus sign here. And that would be my answer. So sine kx integrates into minus 1 over k cos kx. Right, let's take a look at the next question. And the next question is a little bit challenging. And in this case, I'm integrating sine squared x cos squared x dx. And in fact, I can't integrate, we haven't taught you any way to integrate sine squared and cos squared. The only way is to change it to double angle identities. Use the double angle identities in order to integrate this, because we haven't taught you how to integrate that. The only way is through double angles. Change it to double angles and then you're able to integrate. And I'm going to take you here through this first. And imagine I have cos 4x. Imagine I have cos 4x. Now from the angle identities, I am telling you that it's equal to 1 minus 2 sine squared 2x. Is that correct? Yes, it is. This is double. This is single angle. Well, it's double, but you know what I mean. It's half whatever 4x is. Okay, so in fact, this is actually correct. So I can say that this is equal to 1 minus 2 sine 2x all squared. You can either write the square here or it's the same as all squared. So this is fine. I can then follow it up and say that this is equal to this is equals to 1 minus 2 and sine 2x is 2 sine x cos x. It's one of the identities. So one of the identities is sine 2x is 2 sine x cos x. Again, we've written at the top of this document. Okay, this means that 1 minus 2, and then I am going to square everything inside the bracket. So I'm going to go 4 sine squared x cos squared x. And I'm too lazy, I'm going to cheat and I'm going to go 2 times 4. I'm going to stick an 8 here. I'm going to take the brackets out and write an 8 here, which is 4 times 2. I've squared, basically, just a recap of what we did. 2, I've squared it because the bracket was all squared, so it became a 4, and then the 4 times the 2, that will give you the 8. So 2 squared, which is 4, times the 2 is 8. And then sine squared, cos squared, x. Okay, so let's compare this to my question. Or let's carry on manipulating. Let's manipulate it a bit further before I then go back to the question. Now this means that I can go cos 4x, or okay, fine. Let's write the cos 4x on the other side. I can go 1 minus cos 4x, and I can move this to the other side here. So I can go, this is cos 4x, cos 4x, cos 4x, yeah. So I can go 1 minus cos 4x, and that is equal to sine squared x, cos squared x, and I can divide both sides by 8. Let's try again. Move minus 8, or I'll tell you, okay, let's add 8 sine squared cos squared to both sides, and then let's subtract cos 4x from both sides, and then divide by 8. Okay, so basically manipulate this, this one here. Okay, right, so sine squared cos squared, I can in fact replace it by 1 minus cos 4x divided by 8. So let's go back here. Oops. So sine squared cos squared, so in fact, this bit here, I can replace it by 1 minus cos 4x divided by 8. So let's go back here. And in fact, I now have changed my question to the integration of, instead of sine squared x cos squared x dx, now I have changed it to I'm integrating 1 minus cos 4x divided by 8 dx. And I can kick the 1 over 8 out of the integration. Okay, instead of writing it as sine squared x cos squared x, I can write it as 1 minus cos 4x divided by 8, right? So I can kick the 1 over 8 out of the integration. And I can, and what I'm integrating now is 1 minus cos 4x dx. Easy peasy, let's integrate 1 over 8, bracket. Now 1 integrates into x, because 1 is x to the power of 0. Increase the power, divide by the new power. Increase the 0 to 1, so it's x, minus cos kx integrates into 1 over k sine kx, right? So I'm going to have 1 over k, k is 4, so 1 over k sine kx, so 4x plus c. Sine, cos, minus sine, minus cos. I'm integrating this way, and I'm integrating cos, so you get a sine. And because it's a sine kx, you go 1 over k sine kx. Because it's cos kx, you go 1 over k sine kx. Okay, and that is the answer of the integration of sine squared cos squared dx. I hope you have found this video useful, and I'll see you at the next video. Bye.